I'm Alex. In this orange t-shirt is also Alex. We like to keep things really simple. We've got a few of our friends around here. Now, they all have their own names, but if you want to just call them Alex, that will work really well. Alex over here, two Alexes over here, cool. So today we're going to do a GitOps tutorial. And what we've found in the dry runs is a couple of things that are really useful to do before we start, okay? So one, connect to the Wi-Fi. So you've got internet because you'll be needing that shortly. The second thing is we've got a Slack channel here. If you use this bit.ly link, you'll be able to sign up with your email. And there's a channel in there called #GitOpsWorkshop. And that's a good place to ask questions and to get help from people. And actually, if you want to help, then maybe just the person next to you might be able to help you. And if you see somebody struggling with something, maybe you could help them out. And also, we've got people in these lovely, delightful orange T-shirts floating around in the venue who just put your hand up, and hopefully they'll come over and give you a hand. Come to the front, loads of space. Log into github.com. Maybe use GitLab, but today we're going to use GitHub. And just test you can clone a repository. And we've also found that people have a little bit of trouble pushing to Git repositories on github.com because sometimes they use the HTTP link rather than the SSH link, and they haven't authenticated. And we're doing GitOps today. And what do we need to use for GitOps? Silence. Git. We're using Git for GitOps, so you need to be able to use that. Finally, initially we said install like Brew or Chocolatey, but actually the real tools you need installed on your laptop, if you're going to do the hands-on, are customizing Git. And you'll get a lot out of this section if you don't do the hands-on, but you'll get even more out of it if you do it. OK, great. If you're stood at the back, I'm just going to reiterate, come to the front. There's plenty of places to sit down. There's also plugs everywhere as well. OK, just a little bit. OK, so just I'll go back a second. I've left a link down here in the bottom right-hand side of the screen here. That's going to stay up for the first few slides. If you want to go back and find those instructions, click on that link. That'll help you out find those ones. And that'll just be up there for the first 10 or so slides. OK, what are we going to do today? What are you going to learn today? So this is a nice kind of Venn diagram. I don't know what you would call this, not a Venn diagram. We're going to talk a little bit about the what and why of GitOps. We really want to give you a really fundamental understanding of the core principles of GitOps. They're really useful because once you have a good handle on those, then you'll be able to abstract from them and understand a number of other things about GitOps. We're also going to do a hands-on session where you're going to be checking some code out of Git, deploying that code into a cluster that we have set up, performing an upgrade on that, so like updating an image tag, and then we'll do some troubleshooting of your app when maybe it'll go wrong, maybe. And also there'll be an opportunity for discussion. Maybe we'll have a Q&A at the end, but also if you've got questions, just go back to that Slack channel and you can obviously ask there. My colleague Danny over here will be asking your questions. And also maybe introduce yourself, I'm Alex, I'm from Intuit. You could maybe introduce yourself and say who you are and where you're from. Okay, moving on. Okay, a little bit about who the hell are these guys? Why should I care? Well, my name's Alex. I'm a principal engineer at Intuit. I work on Intuit's modern SaaS platform, which is around a 2-year-old Kubernetes platform that we're working on. Previously, I worked as the EMEA architect on QuickBooks Online in Europe. Anybody here use QuickBooks? TurboTax. Oh, obviously, what's TurboTax? I worked on QuickBooks, not TurboTax. I can answer questions about that. I'm also a blogger and author. And my colleague, Alex, I'm going to get him to introduce himself.
This is on, right?
Are you on? Yeah.
Awesome. So, as Alex mentioned, I'm Alex as well, and we're working on the same team. We're part of modern SaaS platform team, but we're basically working on Argo CD. And even before Intuit, I worked on Argo as well at a different company, which was acquired by Intuit. And as you can see on that slide, there is a link to a book, which I'm co-authoring with a few of my colleagues. So there is a discount if you use it. You cannot. I'm sorry. Okay, that's much better. Let me start from beginning. So my name is Alex as well, and both Alexes are working on Argo CD projects. Even before working for Intuit, I used to work on Argo at a different company. So I'm kind of very experienced in that area. You can blame me for any bugs you see. And awesome. So I'm author as well. I have blogs, and there is a book. If you use that link, feel free to scan the QR code to get a discount. Done. Alex
is probably forgetting to mention that that link will give you 40% off the plug.
I don't know. Sorry.
He doesn't know. He doesn't know. OK, can you hear me OK? Cool.
Okay.
Okay. I also want to get a bit of show of hands. I want to kind of get a bit of a feel for how well people know Kubernetes and GitOps. So I'm going to get you to do one of these hands up things. I know you guys hate it. Get your hands up. Have you heard of Kubernetes, yeah? If you haven't, I mean, you're really at the wrong conference, aren't you? Okay? And if you heard of Git, yeah, Git. Have you heard of GitOps? Okay, okay. Who here's used CRDs? Who's here's written a CRD? Let's get the level on there. Oh, a few people have written a CRD, okay. Who designed the CRD spec? Anybody here for this? Okay, nobody. Anybody here Joe Bader? No, okay, fine. Okay, thank you very much for that. That's good. I think we've got the right level for the workshop. Okay. Just want to give you a little bit of information about Intuit here. So Intuit's been on a Kubernetes journey for around 18 months to 2 years. It's a pretty large organization. We have around now 1,200 developers using Kubernetes on a daily basis. We run 160 clusters, which are all managed clusters. And we have around 62,000 pods. And we do about 1,300 deployments a day. And this graph down here will just kind of show you the accelerated line of adoption of Kubernetes at Intuit. Every time I do any kind of presentation about stuff we're doing, I have to update this slide, and it always goes up by 10 to 20%, so you can never really use this slide. And that's quite nice to see. We've actually updated this slide twice in this deck during the time that we've been preparing it. We're going to talk a bit about Argo shortly in this presentation, but we also do a number of other open source projects. Admiral, which is a plugin for Istio. We also do Keiko, which is a selection of cluster management tools for managing nodes. And if you want to hear a bit about that, Shri can answer your questions. And we also do Argo, which is a selection of tools for Kubernetes. Probably the most well-known one is Argo Workflows, which is a workflow engine, which is very popular in the ML community. Has some quite interesting conversations with people doing weather forecasting using that at this conference. And Argo CD, which is a GitOps tool for GitOps. And also a new one called Argo Rollouts, which some of you may have seen a presentation on that yesterday morning. I hope you enjoyed that. Okay, well, what is GitOps? It always takes me a couple of moments to think about how to describe GitOps to an audience, because you can always describe pretty much anything in one or two ways. You can describe it as the what. And what is the implementation? And you can talk a bit about the why, or why would I want to do that? And those are both kind of good ways to describe any kind of concept. What GitOps really boils down to is you describe your software system in Git. So you basically put all your files into Git, and that describes your software system. Because we're doing cloud native, your software system is Kubernetes, so those files are going to be Kubernetes manifests. And then you have a piece of software called an agent, which just means a bit of a software. And the job of the agent is to make sure the live system, which is your Kubernetes cluster, is the same as your target state described in Git. So really, the agent's job is to get your files from Git into Kubernetes. That's a really high-level description. Okay. So what does that really boil down to? Just three key components. A Git repository for your manifests, an agent, a tool to get your manifests from Git into the third thing, which is a Kubernetes cluster. And these are just the really three key things you need to know about. But nothing's ever really that simple in practice. There are three other things which are really useful. Really, to get the most value out of GitOps, you kind of need these three other things. The first thing is a manifest generation tool. So typically, you won't want to deploy the same set of manifests to two different environments. You'll probably want to deploy a different set of manifests to your production environment as to your development environment. For example, number of deployment replicas or DNS entries. So having a tool that can template those manifests is incredibly useful. And two kind of popular tools that I'm sure everybody here knows about are Kustomize and Helm. And there are a few other tools in that workspace. And we're going to talk a bit about Kustomize and Helm later on. And actually, the hands-on section will include quite a bit of customized usage. So that's why it's kind of helpful to have it installed on your laptop. The second one is the CI system. So GitOps is very much a CD process about getting manifests from Git into your cluster. But it doesn't really take any of the responsibility for determining what goes into those manifests. And a really common GitOps pipeline actually starts with a CI job, which builds the application, runs the unit tests, finally creates a Docker image. And then that typically triggers the CI process by making a commit to a different repository to, for example, update that image tag within those manifests. And the third one, which is pretty useful, is a way to group the Kubernetes resources together. And there are a couple of different ways of doing this. For example, you could group them by cluster or by namespace. And the one that we like particularly is grouping by label, because that's extremely flexible. And the reason you probably want to group your resources together in GitOps is because you typically won't want everybody in your organization to be able to create and delete every kind of resource. You might want to restrict certain sets of resources to certain teams. And there's no hard and fast rules around how you do that. For a smaller organization with one team, you might want everybody to have read-write access. But if you're a larger organization with lots of automation, then you might have a lot of tooling around this. You might be quite restrictive in how you allow people to do it, even to only allowing specific individuals within teams to do deployments. Okay, that's the what. But what about the why? Why would you want to do GitOps? So the primary reason you want to use GitOps is it provides you a single source of truth. You've got all your files version controlled in Git that everybody can read, everybody can see, rather than having your files spread across different people's machines or in some inaccessible database somewhere. And it comes with a lot of benefits of using Git. So you get all the security of Git. You can control who can read and write to repositories and therefore who can deploy applications. That gives you compliance, and also you'll get an audit trail. You'll know by looking at the Git history who's done what and when. It's a very developer-centric workflow, so typically a lot of developers are using Git to version control their application code. So you're just using the same tool again to version control your deployment configuration. So by deployment configuration, I mean manifests. One nice feature is it trivializes rollback. So if you release a new version of application and it doesn't work because it goes into crash loop backup or some other reason, all you need to do is just check out the code from Git that was a working version, and then your rollback is very easy to do at that point. Maybe an unsung benefit is declarative. So if I want to find out what's meant to be in my cluster, I just go and look in Git, and I can find that information very easily there. And it also gives you a thing called observability. Now, this is a bit nuanced, and we'll see a bit more about this later on, but the ability to see what's in Git and what's in your cluster and compare the two and see those differences is incredibly useful, because it's going to tell you what's going to happen if you were to roll back or if you were to release a new version of the application. And one that maybe I wasn't really aware of when I first started working in GitOps was velocity. We hear this feedback a lot from developer teams that it's just really quick to get your code out into production, to get that fast feedback loop. Okay. What we're going to do now is I'm going to do a quick demo. And this code is in GitHub. You can check out these links. I'm going to bring it up now in my other window. We're going to do poor man's GitOps. So what is poor man's GitOps? Well, that's basically if you don't want to install any kind of application to do GitOps, this is what you could do just using standard Kubernetes resources. Okay, my apologies.
You go.
Okay, so the first thing we do, obviously we need an application to deploy. And what I've got here is a very basic application called, I've called it my app. Maybe I should have got something else. And if I just run this application, we're going to use this again throughout the demo. This application doesn't do anything particularly fancy. It just prints the word howdy or hello or whatever greeting you want to the console about once every second. And we're going to use that a few times through the presentation aspect. Okay, what do we need for GitOps? Well, we need a Git repository, we need a Kubernetes cluster, and we need an agent. And so you can actually build your own agent. And let me just show you how to build your own agent using just a standard Docker file here. So this Docker file, it just installs the very basic tools for an agent. It installs Git, so you can get your files from Git. I install the getx library because it contains a command line tool called msubster. And msubster is the most basic templating tool I could think of. It basically, if you take standard in, you cat it to msubster, and then it replaces any dollar variable names with environment variables. It's a very basic templating tool. And obviously kubectl, because the third component is the ability to speak to a Kubernetes cluster. And then I've got an installation.yaml file here, and this contains a couple of different things as well. So I've got a cluster role binding and a service account so that my cron job can speak to kubectl, so it has access, read and write access to those APIs. And I just have this cron job here. Shall I make the font a bit bigger? Yeah, let's do that. Let's tab to a different window instead. So basically we have a cron job here. This is set to schedule every 1 minute. And what it does is it runs this short shell command here. It clones this Git repository. It cats the content of this YAML file through to msubster. And then it passes it to kubectl apply. And then we've got a couple of additional arguments here including a label and a prune. So the label is, talked about earlier, they need to kind of group your resources together. It's really useful, so we're applying a label there to do that. And then we'll delete any resources that we don't find, that we don't want using the prune thing. I've just added validate false because that's what I had to do to get it to work. Don't really know why. So we'll just apply it. So this is in, if you want to run this locally yourself, this is just in our GitOps workshop on GitHub. And maybe Danny can drop the link in?
Yep.
Maybe?
Go for it.
Danny's on Facebook as well. OK, so there we go. We just create our resources. And we can just watch this on the console. I think we can watch this on the console. There we go. And so it runs about once a minute, so we're just going to have to wait for it to run. And when it runs, it'll run that cron job, and it will make me try and fill time, try and avoid any dead air. There it goes. There it goes. It basically just runs a cron job, but that cron job applies it. You can see that my pod has just popped up there in my local Docker for desktop. OK, that's poor man's GitOps. OK, so
just want to jump in, and the reason for that was to kind of show you what pieces are in GitOps. And there are a bunch of tools which implements GitOps, but pretty much all of them is kind of cron job plus kubectl apply. And I think it's important to know that because knowing that, you will know exactly what these tools are doing underneath.
OK. What's the problems with poor man's GitOps? OK, let's just go through 5 problems with poor man's GitOps. And this maybe sounds a bit salesy, but this stuff really applies to any kind of tools, and we're going to talk about some other tools you can use shortly. One of the problems is security. Obviously, my cron job has read-write access to the cluster. Therefore, anybody who could commit to Git has basically read-write access to the cluster. I might not want that, to be honest. Observability, so it's quite hard to know what's going on there. I don't know the difference between what's in Git and what's in my cluster. I don't know if that's going to work at all, if those manifests are going to validate, so there's none of that kind of features in there. It might have quite big impact, so I could easily make kind of quite a big mistake using this tool. It has latency, so as I showed you there, that cron job only kicks off every minute. You might not want to configure it a minute in production because you might not be doing a deployment every minute. You might have 3 minutes or 5 minutes, but you've got to basically wait for that cron job to kick in to do that deployment. And the final thing is it's essentially single tenancy. So there is only really one team in this model, and we're all deploying to the same cluster. So we can't deploy across clusters, or easily across namespaces and other things like that. So these are kind of some of the downsides, and we're going to perhaps even talk a bit more about this later on. Okay. So we work on a team producing a project called Argo CD, which is a GitOps solution. It's not the only GitOps solution out there. There's another one called Flux. Who's heard of Flux? Yeah, brilliant. I like that. Brilliant. I'm really glad to hear. So have you guys seen the blog post announcement recently? Yeah? So we're going to be working with those guys to produce a thing called GitOps Engine, which would be a kind of a best-in-breed GitOps solution. And we both have 2 products, and they have slightly different use cases. I won't really go into the details, but we're not experts on Flux. We're experts on Argo CD, and that's what we're going to show you today. So I'm just going to give you a little quick. We're going to do a little. So what is Argo CD? Argo CD is this handsome baby Zoidberg here, who's our mascot, and he basically just takes that role of the agent inside your GitOps solution. Here are a few of the names in the Argo community. So we've got kind of some quite big names up there, some smaller names, and we've met some people here today who aren't listed here. So if you are using Argo and you aren't listed here, I'd love to hear. I'd love to get you on the README file if you can do that. And we've got a couple of different repositories here, and you can see we've got nearly 2,000 stars in this repository. And I was saying to my colleague Danny, I wonder who can get the most stars at KubeCon on their repository. Who will get the most new ones? I set him a challenge to that. But if we get 2,000 stars at the end of KubeCon, I will play you the only animated GIF you're going to see at this KubeCon because they don't seem to be very popular anymore, I don't think. Okay, a quick demo. So let me just make this big. So this is the user interface of Argo CD. This shows you the way that we group resources in Argo CD, which is in a thing called an application. An application is essentially a custom resource which defines which repository, path, and revision to get the manifests from, and which cluster and namespace to deploy them into. And then those resources, when they are deployed, they get labeled with that application's name, so we know which resources make up part of an application. I'm just going to pick out the cert manager here to show you a little bit around this user interface, because you're going to see a bit more of this shortly, but it might be quite nice to know a bit about this beforehand. So this shows you my application. This is the cert manager application. You can see there's a number of resources in there, and we can see that some of these resources have a nice green tick to them next to them, which tells us that what's in Git is the same as what's in our cluster, which is really important to know. And some of them have small yellow X's that tells us that actually there are some differences between that and what we expect. And we can click into those resources, and it'll actually show us here in the interface what, on the left-hand side, what we've got in our cluster, and what on the right-hand side is what we really want to have. And this typically shows you the difference between the deployed commit and the commit that's at the head of your branch. And this information is also aggregated up. So at the top here, we can see that this application is healthy, which is indicated by the green heart, but it's out of sync with Git, so we know that there's some changes. So maybe we want to get the application into sync with Git. Okay. The hands-on. So I hope this is the bit you've all been waiting for. Do you have your laptops ready? I hope everybody's managed to get through those instructions. If you have had any issues, then put your hand up if you haven't been able to log into GitHub, and maybe somebody can help you out on that. Should I just remove my laptop from here? Let's do that. So I can hand over to my colleague now, Alex, and he will do this part.
Can you check once whether they can see at the back?
Mukriko was just saying, if everyone able to see the screen, even at the far side of the hall. Sorry about that. Can you hear me well? Okay, and please raise your hand if you're unable to see the screen. Oh, okay, got it. All right. So. Thank you. Oh my God, how come it's so long? Right, let's get started. So, before I close that screen, I want to say thank you to DigitalOcean, because they gave us awesome Kubernetes cluster. So, I want to give them credit, and if everything is not working, you can blame them too. But it's a joke. So we did testing, it went well so far. Okay, and as a next step, please open that URL. Oh my God, yeah. I'm going to pause for a second to let you, read the URL and try to type into your browser. And I see that a bunch of people already opened it and even did some steps of the workshop. Please don't do it yet. Okay, and I'm going to open it as well. So before we jump into the exercise, this is basically, you can use that repository later on, because it has all the steps which we are going to do in a workshop. So if you're stuck today and something doesn't go right, this is pretty much instructions of what you can do to repeat this workshop. Okay? Make it bigger. Thank you. Yeah, I'm going to forget things. Please bear with me. Okay, and I'm going to give you just a brief overview of what is in that repo. It's pretty basic. Because we're doing GitOps, it has a bunch of YAML files, which are Kubernetes manifests. And because we want to make it like a real life, we don't want to just have just YAML files. We're going to use some templating tool. And our choice right now is Customize. Later on, we will talk more about Helm and Customize and what works better in which cases. For now, it's Customize. And we try to make it as simple as possible, because it's a demo. So we have a single resource, which is pod, and we're going to deploy it in a few minutes. And we have customization.yaml file. And all it does, it basically tells to Customize that it's supposed to use that pod as a resource. Okay. And as many of you seen before, we had a bunch of prerequisites, and one of them is to install Customize. I hope you did it already, and I did it before the workshop. And let's go ahead and verify that you have it. Screen is big enough? Bigger? Awesome. Well, this is my Customize.
Bigger still.
Still bigger? Okay.
Bigger.
That's really big. This is giant. Cool. This is my customized. I use 3.1. Please install at least 3. Something because customize changing quickly, and I cannot guarantee it's going to work on 2. Awesome. So I think we're ready to start. Please raise your hand if you need some more time. See no hands, so let's get started. And the very first step which we're supposed to do is to fork repo. Wow, I see 92 forks already. This is good, but for those who didn't...
Refresh the page.
Yeah, wow. Okay. All right. Please blame DigitalOcean.
We've got 178 people who are well ahead. Well done.
Awesome. So, and the reason you have to fork it is because we're going to make changes in the repo, and each of us will do these changes, and basically you need write access. And we're not going to give you password of our repo, so you will have to use yours. And awesome. So everyone forked. I hope we are not going to get 100 more forks. So we're getting...
Don't count on it.
All right. So, and I don't really need my README file to guess what is the next step, because next step is to clone the repo. Before you clone, please make sure it's a suggestion to use SSH URL. And the reason is it's just easier to push. If you're a GitHub user, maybe you have SSH key configured in GitHub. If you don't, you will have to use HTTPS and use username password. That's more work, but that works too. So, okay, I'm going to clone the repo. And great, so we have the repo. And I'm waiting for everyone to do that. Unfortunately, I cannot verify that you cloned the repo. There is no information. And we're ready for the next step. It's still basically preparation. I have these shell scripts. You can use them as basically you don't have to type. You can just copy paste. And first step is to set this environment variable username. It is not only just to clone your repo, it is also, it will be used later on. And important piece here is to use your GitHub username as a username, and please use lowercase. And the reason is we're going to use that same environment variable to give a name to a Kubernetes resource. And as you might know, Kubernetes resource is not allowed to have special characters and uppercase characters. So please use your lowercase username.
We're hoping that nobody has the same username as yours, uppercase and lowercase. We're assuming.
Yeah. Okay.
So you guys probably know that what we're going to do at some point is we deploy an application. Now, what we can't really do is create 300 namespaces for you. So you're all going to share a lovely big namespace together, and we're going to give each one of you a unique name for your application, and we're going to we recommend you use your GitHub username for that, because we can pretty much guarantee nobody else will have it, unless we're wrong about the uppercase thing. Don't think we are.
I don't think so. Yeah, I think it's a...
We're about to find out.
Yeah, all right. Cool. I already skipped this part, and I cloned the repo, and I hope you did too. And next, the last preparation step is to actually change your current directory to your cloned repo directory. Yeah, a good suggestion for my colleagues to verify that everyone is here so far. If not, please raise your hand, and there is help around you. People can help you. Awesome. I think we're ready to start. So finally, we're all developers? No? And I hope everyone has customized. We're ready to make changes, push them back to Git, and deploy.
Everybody has installed customized?
Yeah. Okay. So actually, next step is to verify that. So if next command fails, customize is not installed, or maybe it's a wrong customized version. So next step is to use customize to get the final YAML files which you're going to install into your cluster. And the reason we pick customize is because it's useful to customize the template of your application. So as I mentioned, in the repo we have a resource and a customization.yaml file, and those two files are in a base directory. And this is the typical pattern of which customize encourages developer to use, is to create a base template of your application, which you can customize later on. And usually you want to customize it to create a bunch of resources, bunch of environments, And in our case, each environment is an application which is specific to you. I want to make sure my base is actually working. To do that, I need to run this customize build base command, and it produces a YAML file. And as you can see, right now it uses my app as a name of my pod, and it uses some predefined image with a predefined version with no changes from the base. And next step is to create an environment and push it back to your fork. And you don't have to use that command, but it will help you. You can simply copy paste this mkdir command and use overlay -dev/dev as a folder name. And next we need to create some files in that folder. Basically, we need to create a customization.yaml file, and you can use that bash snippet to create it. Or if you want to, you can type it yourself.
Do we want to talk a bit about the customization file?
Exactly. That's what I'm going to describe it next. Yes. So once you've done this step, I want to pause a little bit and just say what we just did. I'm going to use div command, although my colleagues are trying to stop me still, but trying to slow me down. Actually, no, I want to use.
Well, while he's doing this, just a little bit about the layout of a directory structure for a customized application. Typically, you'll have a base directory which contains your kind of default set of manifests, and then you'll have a series of overlays. An overlay basically is a list of changes to be made to the base manifests for different environments. And they're typically in a directory called overlays/name of environment. So you might have overlays/production or US-West1 or QA or whatever you want to have in that. And for to be able to run customized build in that directory, you need to have a file called customization.yaml in that directory. And that basically is the configuration for that particular customization. And what we're doing here is showing how to create an overlay for your development application. And this will be customized for you individually.
Mm-hmm. Yep. So this is just a cut output of customization.yaml file. And as you can see, it uses base as a base for my application. And next we can just try to build it and see what happens. So please copy paste this customize build command and execute it on your laptop. And basically you should see exactly the same output as output of a previous base command. And the reason is we made no changes and we use existing base directory as a base for our new customized application. So this is great. Let's save what we've done. And okay, I don't think you need help from me, but you can still use that snippet as help. I'm just committing my change back to Git, and I'm pushing it back to GitHub. This is a great start. Now we have a customizable environment, and next step is to actually customize it and make it deployable into environment, which we have. Okay, I see a lot of people typing, and that's why I'm going to give you a few minutes to actually complete the step. So as you can see, I just pushed my changes. They're available in my Git repo, in my fork. If you didn't fork before, and if you did all the changes using upstream, maybe you're in trouble now and someone trying to help you. Okay, please raise your hand if you still have issues. If not, I'm going to continue. And I'm going to quickly check our Slack. Awesome.
Just checking in on the stars here. We're getting a few stars here, Danny. So I feel like you might be buying the beers later on. That's what I feel like.
We haven't shown Argo yet. So.
I like IPAs, and they have some nice ones in San Diego, just for reference. The Slack link is expired. Okay. The way we'd normally solve this is by pasting a link into Slack, but that's not a problem, is it? Let me try and sort that out.
I'll paste the full link to GitOps channel in the Kubernetes Slack. So if you get to Kubernetes GitOps Slack, I'll paste the link to our Slack.
Okay, cool. Oh, sorry. Jesse said, "What if you're in the Kubernetes Slack? He's going to paste the link to the Argo Slack in which channel, Jesse?
GitOps.
GitOps. I don't know why I asked that question. Obviously, GitOps.
We still have plenty of time, so yeah, I'm going to give everyone a chance to complete that step and get ready for exciting step.
Should we talk a bit about Helm and Customize for a moment? So you guys are probably noticing we're not using Helm for this, and the reason we're using Customize predominantly is because that's something we use internally, partly because that's what we've used for the workshop. We find they fit quite different use cases. Customize is particularly good if you're consuming your own software within your own team, because it's very easy to create manifests. Helm actually excels at packaging applications up for others to use. It can be a bit of personal preference. It's just for us today, Customize makes this workshop a little bit easier, and that's why we've chosen it.
Yep,
there are other tools out there.
Alex mentioned before that we're going to deploy an application into the same namespace, and obviously we don't want to step on each other and delete resources or like override resources of someone else. So at the next step, we're going to use one of customized features, which is name prefix, and it's a very convenient for that workshop to make sure everyone uses a unique name for each resource.
We got any customized contributors here? Yeah, come and say hi afterwards. We'll have to have a chat.
Okay. And actually, a perfect time to ask, did anyone use Customize before? And cool. Actually,
brilliant. Right, if you're having a problem, ask these guys. Ask these guys.
Okay. Meanwhile, I can check number of forks, which is close to 300. I'm extremely impressed. I was hoping to see a two-digit number, which will make it much easier. Okay, guys, yeah, I think it's time to move forward. And in case you're really stuck, there is a chance to repeat it again. And please, feel free to reach out to us on Slack. We're happy to, help you with it, even after the talk. So I'm going to continue. And as I mentioned just now, I'm going to change the name prefix of my resource using Customize. And we're at the step 6. And as usual, you can just copy-paste these bash commands, which I'm going to do, or you can make changes yourself using your favorite text editor. And I prefer bash because it will be much easier. So first of all, we need to make sure we're changing current directory and go to overlays-/dev. Interesting. Okay, we'll see you later. Okay, go ahead and change the current directory to overlays/dev. And next step is to change name prefix of resources which you're going to deploy. There are two ways multiple ways to do it actually. One way is to just go ahead and modify the YAML file, or use Customize patch, or use a feature of Customize called name prefix. And you might guess from the name what it does. Basically, it will make sure that every resource included into your customized application will have a specific name prefix. I hope you have an environment variable still set username. If not, then just type your username here. Don't forget to use lowercase. And if you successfully run that command, you can just run git diff and see what was changed in your repository. And this is what you should be seeing. You should just see a new field name prefix and your username. Sounds good so far? Please raise your hand if you need help. There is someone, and help is coming. Okay, and if that was successful, we can make sure that customized build is actually producing what we expected. So the build should make a slight change. Because we have just one resource, just this resource was prefixed with my username, but the beauty of that feature is that if you have 10 resources, you don't have to go and modify all of them. It will be taken care by customize. Cool. So if everything is going smooth so far for you, it's time to commit the change and push it back to GitHub.
I think for the Windows people, customize is taking longer to build.
Okay. Yeah, so if Alex, if you have an exciting topic to talk about, feel free.
If I have an exciting Alex thinks I'm like the comedy relief here. His job is to do all the hard work, and I'm the job to make the jokes, which is only probably about 70% true.
Yes, so the reason is we did not. So the question is, why do we set the pod name instead of just use a namespace to basically namespace? Is that the question, right? Yes. Yeah, the reason is it would be like extremely difficult for us to automate namespace creation for like all of us. So we decided to just use customized feature of name prefixing for the demo purposes. But in real world, yes, the suggestion, basically at Intuit, we suggest to create a separate namespace for each application to basically don't worry about name collision in the cluster. Yeah, and the second reason, of course, you can use namespace to isolate applications from each other. So you can use network policy, for example, to prevent them from talking to each other and all other benefits.
I think we're getting another question.
For some people, the syncing is taking a couple of minutes.
And I'm using a moment to answer a couple questions on Slack. Oh my God, it's going out of control. So I see that some people are quicker than others, and we have like a couple dozen of applications already. Please wait for us, wait for everyone. I hope no one is mining Bitcoin yet on DigitalOcean cluster.
They don't like that.
Continue. Time to continue.
We have a question? Maybe we can get a microphone. It's quite far away. I need help, or is it I have a question? Let's find out.
I actually just wanted to ask a question. Like, this looked really.
Okay, cool. Okay, I think we're good to go.
Okay, I think it's time to move on. Let's continue. And so far it's been kind of boring. Every one of you edit files before and push it back to Git. I hope now you will be more entertained. So it's time to take what you've done and deploy it into a real cluster. And for that workshop, we did something really brave. We created a cluster, and we gave everyone on GitHub admin access. And if you have a README file open, you can see the URL of Argo CD instance, which we created for that workshop. Please go ahead and click on it. And you need to log in. There are two ways. Basically, you either know the admin password, which we are not going to tell you, or you can just click on login via GitHub URL. And you will have to confirm that you trust us. And basically, we'll know your email. That's it. Nothing else. So if you click authorize, oh my God, you should have seen an empty screen here.
We're expecting an empty screen here. It's quite nice to see this.
And yep. So I guess thanks for Alex's introduction, or maybe here everyone here knows Argo CD already. So
the
somehow
end of the workshop. No, okay. Oh, carry on. Sorry.
No.
If everybody knows it, we'll just finish here.
No,
we can all go and get this beer that Danny owes me. Okay, we'll carry on. Yeah, we'll carry on.
Absolutely, yes, we carry on.
I have to wait, I guess.
Yep. Luckily, like 100 people already managed to finish workshop, or at least get very far there. But I'm going to kind of reiterate what Alex demoed a little bit earlier, and I'm going to walk you step by step and explain, like in more details, what Argo CD application is and what is that all these things on this UI means. So basically, if you want to deploy something using Argo CD, you're supposed to create an application, which is just Argo CD abstraction. It's a way to group a bunch of resources. You can group your whole cluster into a single application, or maybe you want to group, just set of resources which you care about. And as everyone did before, what we just did, we just created a source of manifests for our application. And we're going to try to deploy that set. So basically, first thing we need to do is to click a new app button and give it a name. So your GitHub username is a perfect candidate for that name. It will be most likely unique. My GitHub name is AlexMT. Don't worry about project for now. Usually project is basically a team. We are one team right now. And please do not destroy your teammates' applications. So the sync policy is for demo purposes. I want to set it to manual. You can set it to automatic if you're really brave. It's not really recommended in production. And next meaningful input is the source of manifests. So I suggest you to use your GitHub repo URL, and please make sure to use HTTPS URL. If you use SSH, you would have to configure keys, just because SSH clone requires some keys. It is possible, but for the demo purposes, let's just use HTTPS URL. And next is a cluster. So Argo CD, this particular instance, is configured to deploy into the same cluster where it is running. And namespace, for simplicity, is default. You can choose any other namespace, but basically, you would have to guess a name of that namespace. And I'm just telling you that default is available. And this is it. That's all you need to deploy an application. And if everyone with me, I see that everyone already here. Please click Create button.
Now we just begin Thursday's load test.
Oh my
How many
God.
apps can we create?
Somehow I managed to screw it up. So I put, okay. So the repository URL is supposed to be in the repository field, and there is a path. And path is just a directory inside of your repo. Argo CD kind of tries to help you here. It searches all the directories inside of your repo, which are possibly application. So it understands customize, Helm, KSONet. So it notices there are 2 customized files in my repository, and please use overlays -dev because it is specific to you. It has name prefix. Cool. Now I'm ready to create it. And yeah, here I am. I guess I'm lucky because my name starts, from A, so I can see my application right away. If you don't see it, oh, someone just added one more. If you don't see your application after you created it, there is a search bar, and you can just type your username and click enter. Okay, and so as you can see here, 2 of my applications are the resource of my application has this cross next to it, which indicates that something is not right with it. I can click on it, and I can see exactly what is different. And the difference is just missing in my cluster. And if you're following me, you should see the same picture. And the way to fix it is to sync. And sync is also, it's basically a term introduced in Argo CD. We call deployment process a sync because this is what it is actually. It's just syncing your GitHub, the state defined in Git into the cluster. So please go ahead and click sync button. And you will see this panel which kind of showing you what exactly you're about to do. In my case, I'm going to push a deployment, which name is some name. Push a pod, which has the name. And this resource was taken from that repository, from revision, which is head revision of my repository. So please go ahead and click sync button. And the plan was to show you, what is happening in our cluster by going to applications list page and open that chart. Surprisingly, we have already 200 applications roughly synced, and 150 of them are running. And to be honest, I'm happy already because I didn't even expect us to get to this stage. Something must blow up before, but it didn't happen. And at least now I have some feedback. I can see that chart is still changing. That means people keep clicking sync button. And meanwhile, I kind of wanted to point out that I personally feel like this is impressive already, even though all we did, we just deployed it. But basically, I was really impressed how 100 people managed to do it without guidance. And yeah, there is quite unusual way to use continuous deployment tool is, when you're deploying almost 200 applications at the same time. It's still moving, so I guess people still deploying.
Okay.
Okay, I guess while you're still syncing, I want to demonstrate you a few Argo CD features which are useful after your application is deployed. So in addition to doing GitOps, Argo is pretty much a tool, it's basically a Kubernetes dashboard. So you can use it to see what is in your cluster. And you can use it to troubleshoot issues. And if there are no issues, you still can get some useful information. You can see what resources are included into your application. So in our case, it's just one pod. And still you can click on that pod and you can get some summary information about the pod. You can check the manifest, which has pretty much everything about it. And you can check the differences, which is empty right now. So that pod is using exact same spec, which is defined in Git. So And you can see it live. So you can use logs tab to see what is happening inside of your application. So, and that sample application is just keep printing the hello world text. Let's go back to our chart and see how many applications are still unsynced. Okay, I feel like whoever not synced it maybe stuck and maybe need help, and because that number has not changed much. So let's continue. And finally, let's do some GitOps deployment. And unfortunately, we'll have to go back and change the Git again. And it might be boring, but this is, I think, essence of GitOps. Basically, it's very robust. Once you make changes in Git, you should be able to deploy to that stage, and later on, you can easily roll back. So first of all, let's deploy. Let's make a change. This is step number 9, and it will be really easy for you if you go back to your repository, open README file, and scroll down to step number 9. And next, we can use another customized feature to make changes in your application. So basically, as you can imagine, to upgrade an application, maybe you want to you want to change an image. I already created an image for that workshop, so you don't have to build it. And all you have to do, you just have to copy this bash command, run it, and run git diff to make sure something meaningful happened. It worked for me. My customization.yaml file got a new section called images, and just want to explain what it is supposed to do. It explains to Customize that Customize should check every resource included into Customize application and search for images, which name is GitOps Workshop My App, and make sure that image version is version specified in a new tag field. So in our case, it's v2. Next step is to verify that it actually worked and image is replaced by Customize. You can simply run Customize build and check the output. And output should be almost the same, except image version of our pod has changed to v2. And basically, GitOps deploy is git commit. So let's go ahead and commit the change and push it back to GitHub. So in real life, Argo CD would notice the change already. And if I go back to my application, it is still in sync. And the reason is, usually we can configure a webhook from your repo. Now we have 300 repos. It will be difficult to configure a webhook. So to fix it, you can simply click refresh button and tell to Argo CD that you know there was a change. Please check it now. If you don't click refresh, you would have to wait for like 2-3 minutes. And now I actually have perfect data to see if people are following my instructions. So pretty much we're waiting for all the applications to go from in sync status to out of sync. Okay. I guess it would be easy if I go back to README file. So if you could not complete the steps, they are on the screen. Please go ahead and do it. Basically, copy these bash commands, make a change in your Git repo, Git push it back, and click refresh button on your application page to make sure Argo kind of refreshes the state and show you the difference. Let's do split screen. I want to see the progress. Okay. All right. We have limited time, so we have to continue. I want to show you how Argo CD can help you to understand what exactly is different in your application As I mentioned before, you can just click on resource and inspect the differences between state defined in Git and in the cluster. So in this case, the differences is image tag as expected. And I want to go ahead and fix the difference. Basically, I want to sync again. So please click the sync button and confirm the syncing on this panel. So sync has started, and application sync state switched to green, meaning it's in sync right now. And we've got this red mark indicating that application is in a bad state, in degraded state. And that is pretty much, I think, the second important feature of Argo CD, which is enabling a lot of use cases related to CI. I'm not going to talk much about it, but I think you kind of might guess what that means. So Argo CD assess the health state of each resource included into your application, and basically trying to answer, is that resource healthy, unhealthy, or maybe it's still progressing from a healthy state to something else. So in our case, state is degraded. And you can use Argo CD UI to find what exactly happened. And the basically most useful tabs in this case is events. And events tab just showing you normal Kubernetes events. You can use kubectl to get the same data, but with Argo CD, you have a UI, so you can just click a button. And you can see that some container is failing. I can switch back to summary page and see the status detail information to see which exact container is failing. In this case, it's main. And I can click on the logs and actually see the real failure. So we introduced a bug.
We find developers sometimes introduce bugs into the application.
Yeah, this is rarely happening. But
sometimes they don't test them before they push them. Sometimes.
Yep.
One kind of like handy thing to do is actually always run your customized build or your Helm template commands locally. We do get a surprising number of people who don't understand why the applications won't deploy, and actually it's because the applications won't template. So that's always a good bit of feedback is run that before you commit and push.
Yeah. So we're kind of trying to speed up process because we're running low on time, but I do want to check, how many of you broke your application? Awesome.
Well done.
It's going good so far. Yeah.
It's the most buggy applications I've ever seen in my life.
Okay, let's go back and try to fix it. So we do not recommend to do that in production, but Argo CD kind of give you a way to fix the emergency situation. You don't really have to change anything in Git. You can just use Argo UI to roll back to most previous commit, which was deployed. So we just did a couple deploys, so that's why I know that previous commit was successful. And I'm just going to click on this history and rollback button. I will see this table which has list of deploys, which I did, or list of syncs. I'm going to pick the first one from the bottom and roll back to it. And of course, there will be a confirmation window, which I'm going to use to confirm the sync. So once my sync is confirmed, you can see that immediately Argo CD rolled back my application to previous state. It's healthy again, which is great. And what is not great is that it is in out of sync state. And that kind of gives you ability to quickly fix your production issue, but you kind of in a bad state right now because your application state does not match to what you defined in Git. And once things are fixed, you can go ahead and basically do a proper Git rollback. And it's time to do a pause and see how many of you managed to fix your application. It's changing. Awesome.
the nice thing about this is that, we talked about a little bit earlier about how it trivializes rollback. So, just the ability to go back to a previous commit that we know is good, rather than having to kind of fish around and try and figure out what is good. And this is kind of one of the nice benefits of GitOps. The way that I imagine this is you've just done a release at, like, say, 4 p.m. on a Friday afternoon, and a colleague's lost a bet and he's got to buy you a beer. Maybe his name's Danny, and you need to quickly fix this. All you need to go into the interface and you click roll back, and you just go back to the previous version, and you're golden at that point.
Great, and I guess because we're really getting close to that piece of a workshop, I'm going to execute the last step, and I'm going to do a proper Git rollback. And pretty much, as Alex mentioned, with GitOps, rollback is trivial. All you have to do, you can just commit a revert commit, create a revert commit, and this is the git command which you can use to save time. So let me show you what exactly happened. This is the UI which can demonstrate you the change. And that was the commit which I did. All I did, I just changed. I get rid of this images section. So my application no longer overrides the image. So it will fall back to the image tag which is defined in base. So it's going to be version 1. And this is it. That's the rollback. So all I have to do, I just need to push it back and make sure my application is in a synced state. So you did it before. Basically, you can navigate to your application, click refresh button, and see that both statuses are green now. So application is healthy and synced. And just before we finish this part of a hands-on, I just wanted to reiterate on what we did and what we've learned as part of that exercise. So basically, almost every one of you created an application, then most of you managed to customize it and deploy it using Argo CD. And we made few changes in Git to upgrade application to a new version. Then we noticed there was a bug in the new version, and we kind of use Argo CD to troubleshoot it and find exactly what went wrong. And then we used Argo CD to roll back and quickly fix our production. And finally, we kind of fixed the Git state by doing a proper Git rollback. Yeah, so this is it. That's all I had for you. Thank you.
So we're going to continue to show you a few other features here. We're going to talk about Helm. We're going to talk about Customize. We're going to talk about secrets. So this is more demo-related kind of stuff.
Before we continue, I think we just need to ask, I know that not everyone completed the exercise. Do you still want to continue and complete it? Or we have more stuff for you, and Alex can...
More stuff.
Awesome.
I like that. My guttural request for more stuff. Okay.
Yep.
I will throw some paper on the floor. Oh, do you have the slides on yours? Actually, I use mine. Anybody here use Dvorak keyboard layouts? Yeah? I learned this about 5 years ago, and now I can't type on a normal keyboard, which is really annoying when you're typing passwords into machines. Okay, so that's a hands-on. We want to talk a bit about some of the templating tools because they're so key to the success of your kind of GitOps solution. And the two big tools out there are Customize and Helm. And Customize is the one we just used in the workshop. Customize is just a command line tool, so you typically use that by you typically have a set of kind of default manifests and you apply overlays to them. Customize is actually the tool we use into it, and the reason that we use that is it's really good for customizing apps that you're going to consume yourself, because it's super simple to use. Another tool you might look at, and we actually know that a number of companies use this as well, is Helm. Now, Helm is a way to package an application up. You typically take a set of manifests and group them together, and you provide some additional metadata about those manifests, such as the name and the version, and also some values. What those Helm charts are is unlike Customize, which is just plain YAML, the Helm charts consist of manifests that are templated Golang, which is a delightful templating language to use, but allows you a lot more flexibility than Customize. You've got things like if, and you've got loops and other kind of things in there as well. So Helm is really good for packaging your app for other people to use, and actually we provide Helm charts for Argo CD, which you can just install by default, and that's quite good if you're sharing with other organizations, so you're publishing, you have an application you're publishing for other people to consume, or perhaps you're publishing to a different department or BU in your organization. There are quite a number of other tools out here. And one of my colleagues has published this a blog post here, and I put up a QR code if you want to snap that to go and read in more detail about different tools. So we quite like JSON, for example. We know a lot of people use replicated shit. Some people just like raw YAML, you know. And if you've seen, there's a company here called Palomi, and they allow you to template your YAML using any kind of programming language you like. And that's all these are kind of interesting different ways of doing it. Okay. There's no secret that one of the difficult things in GitOps is doing secret management. And the reason behind that is because you're putting your manifests into Git, and obviously a Kubernetes secret contains a base 64 encoded values. So what I'm going to do now is I'm going to give you a little demo of how to do secrets. Now, you can actually do this yourself because this is laid out in a tutorial format. I will not be waiting for you to do that, though. I'll just crack on with it as well. If I can type on my keyboard, after joking about it a minute ago, obviously I can't now type. Okay, so what I'm going to demo is a thing called sealed secrets. So what sealed secrets does, it is an operator that sits within your cluster, and it looks for these resources called sealed secrets. A sealed secret is essentially a secret that's been encrypted using a certificate from that repository. So if you want to do this, you can just brew install kubeseal, which gives you a command line tool you'll use for sealing your secrets. Or you can use Chocolatey. Who's using Chocolatey? Nobody. Okay, it's already installed on mine. And then you can basically just do, as we did before, export your username to be your username. I'm just going to use the standard one for mine. And then you can run this command here. And what this command will do is it will create a generic secret. Here we go. So what I've done is create a secret where the key is a foo, and it reads from standard in, so it's bar, and I can see in my secret that I've actually got that encoded as a base 64 value. And we can actually just easily decode that using in pretty much one of a million different base 64 encoding tools. Just decode that, we can see that's just foo in the bottom left-hand side. So to seal the secret, you just run this kubeseal command, and you pipe the secret into it, and then you pipe the output back to a different JSON file. And that creates a new file called mySealSecrets, and we can actually have a look at mySealSecrets to see what that guy contains. Okay, and so in here I've got a block of encrypted data, which basically parallels the data block, but that data is encrypted. Now I can actually store that in Git, and even people who can read that can't decrypt that secret. But what else have I created here? Well, I've also created my secret file, which I don't really want to keep in Git because it's just standard base 64 encoded file, so I can remove that file, so that's clean, and I can just commit that file up into, oops, copied the wrong thing. I can push that secret up to Git. That's now just in the public domain, that's just in the public repository, and I can now create an app for that. So let's see if I can log in with the secret password. Ooh, so I've got to copy and paste the password here. I don't really want you to see it. How do you do this? What we'll do is we'll do it locally. Okay? I'll just run Argo locally and do that. And takes a few moments to start up locally. I don't know if I've mentioned this before, but Argo's open source software, so obviously you can just download this. We're not a vendor here today to sell you anything. We're just here to demonstrate our software. Maybe it's something that's interesting you, and you might want to get involved in or use yourself. And when he's started up, which takes about a minute or so, we will have a little look at that. Oops. And it just compiles the React, which takes a few seconds as well. Yeah, brilliant. There we go. There we go. Okay, so this is my local running on my Docker for desktop within my cluster. Just check out the context quickly. Okay, cool. Okay, so what I'm going to do now is I'll just create that application in my local cluster using this Argo CD CLI tool. So we've shown you a lot about the user interface during this presentation, but there's actually other ways to create applications. The one way to create an application is using the CLI, which you can just brew install the Argo CLI if you've tapped it. And another one is called declarative management. As I mentioned earlier on, Argo just uses CRDs to store the metadata about its application. And you can just use kube get app to get apps from Argo CD. And we'll see that my new app has been created if I refresh the page. Did I create it on the wrong cluster, maybe? Where is it? Can't see.
I'm quite sure.
He's quite sure I've created it on the wrong cluster. Okay.
In the wrong Argo CD instance.
Which is what happened in rehearsal. Okay, let's log in, shall we? Let's log into the right cluster and secrets password. Oh yeah. We'll create it in the right cluster. I think I've created it in our KubeCon cluster. That's what I've done. That happened. There we go. Here we go. And that's appeared in the user interface here. Okay, so you can see in this application, I'll just make this a little bit bigger so you can see a bit more easily. We've got a sealed secret in there. And if you just click onto this guy, you'll just see it's the diff here says we need to create a sealed secret, which is quite nice. And if I just click sync, it'll do a red square. I'll try again. Oh, the demo gods are not with me today. Okay. Maybe it's worked in our cluster.
It did.
Have a look there.
Here's the URL.
How have I created?
Search for secret.
There we go. I have created it in another cluster as well. Luckily, I've created it by accident in another cluster here. So what we can see that this here has created my actual secret here, and I can open up my secret and see what's going on there. And I can actually see that I've got some encrypted data. And this is another feature of Argo CD that actually redacts that encrypted data from the user interface, so you can't see that. Just to kind of close out on secrets, this is a particularly tricky area to do in GitOps because you're keeping your secrets inside it. But this is not the only solution. We know of like 5 or 6 other different solutions that you can use. For example, getting your secrets from AWS using their controllers. What underlies sealed secrets is actually a set of controllers that live in the kube system namespace that provide you with this information. Okay. So what have I done with the slides? Okay, so what I wanted to do was just see how many stars we've got and whether or not I'm going to have to pay for my beer, which I hate doing. 2014, yoo, brilliant. Right, I promised you the only GIF you'll see. I find this GIF hilarious. I don't really know why. I don't know. I think it's like she gets that we're celebrating something and then she smashes something on the floor. I don't know if anybody's got kids and maybe this reminds you of your kids. Okay, just to kind of wrap up, if you want to come and find out more about doing GitOps with Argo, and if you want to find out more about our Argo CD and Flux collaboration and what we're doing, if you've got questions to ask about how do you secure it, how do you deploy it, how do you set up your teams, how do you organize your namespaces, we can come and answer all those groups. We're from Intuit and we are hiring, so if you're looking for a job, do come and let us know, and obviously you can come and speak to us after this presentation as well.
Awesome. Thank you.